All right, we are in AP Calculus AB. We are on our new unit 5-1. Our title today is Basic Antiderivatives. Giorgio, what's our objective today?
Find the antiderivative of simple general and simple powerhouse functions.
There it is. So going backwards. So I consider basic just mean that the inner is 1. If the inner is something else where you have to worry about dinner, then I consider that to be more complex or difficult. All right, so give me the general idea. Whenever we had a powerhouse before, like pretend I had, I don't know, 2x to the power of 3 and I took the derivative, what was the first step?
Multiplying 3 by 2.
Yeah, you multiply that 3 down into 2, so I would call that multiplying down. So our first step was to multiply down. And then what do we do? So now we have 6x, and then what happened up here?
Subtract 1.
Yeah, then we subtract 1. And again, this is a quick and dirty rule, like I should say, subtract 1 from the exponent. You guys know that you're supposed to subtract 1 from the exponent, that turns into a 2. Here's how you go backwards. So instead of doing this step first, I'm going to do this step first to undo everything. So instead of subtract 1, this is going to say add 1. Okay, and guess what's going to go here?
Divide.
Yeah, divide.
Divide up.
It's still divide down, actually. And then this is the point where you say, wait a sec, Mr. Sindel, 2 steps, 3 steps, what's going on? And here's the trick. What happens if I was taking the derivative of 2x to the power of 3 plus 5? Isn't that still 6x squared? What if I was taking the derivative of 2x to the power of 3 minus 100? Isn't that still 6x squared?
Yeah, what if we never knew?
We have to allow for the possibility that there was possibly some number there. So that's why we say add c. C for constant. Maybe there is some other constant there that we don't know about. Okay, so let's go ahead and erase my example. Let's do an
That
actual
covers subtract 2 because it can be a negative, right?
Yeah, well, c could be a negative. If c
Yeah.
is like a -3, then I add a -3. That's really subtracting 3, right? So c is just, it represents any possible constant. All right, so let's first go forwards. 5x squared. If I take the derivative, you do this one home.
5x squared.
Take the derivative.
10x.
10x. Done and done. Now, this literally says take the antiderivative. Go backwards with the derivative of 10x. Well, if I go backwards from 10x, let's make sure, I know the answer is 5x squared because forwards and backwards, right? But let's try the rule. So I'm going to add 1 to the power. So this turns into an x, not 1, but x to the power of 2. And then what am I going to do with this 2?
Divide.
Divide down. 10 divided by that power. So we'll say 10 divided by that power. And then don't forget to b plus c. So this turns into 5x squared plus c. All right. How are we feeling about our first antiderivative? Feeling good? Feeling okay? All right. So, of course, I'm going to increase the dial of difficulty, of spiciness for these problems. Let's see what happens here. So, I want to go backwards. This is saying the antiderivative of that function. And then this is the point where you say, what is this? What is this dx? And I'm going to say, ignore you for now. I'm just going to ignore that. This symbol and this dx go hand in hand to say, hey, which variable am I going backwards with? I'm going backwards with x, which is why we have an x there. But for now, let's ignore the dx. And these symbols go away when I take the antiderivative. So essentially, I'm taking the antiderivative of just -2 squared of x. Well, if I have a radical, that's still not okay. I need to anti-radical that. Giorgio, do that for us.
Half.
This is really supposed to be
Half.
the antiderivative of -2 x to the power of 1/2 dx. You do have to write the dx to be formal about it. And now I'm going to take the antiderivative. So, Giorgio, again, this x is no longer to the power of 1/2. It's x to the power of what?
half.
1 and 1/2. Well, if I do 1 and 1/2, that's the same thing as what?
Three halves.
3/2, yeah. So you should be comfortable jumping from 1/2 to 3/2 kind of in your head from now on, because it's a very common thing that you'll add to halves. Okay? And then I still have a -2 up front. That's still the coefficient. I'm going to do that with a non-laser pointer. What do I do? What was the second step? We add the 1 to the power,
Divide down.
divide down. So how do I divide by 3/2?
3 times 2 is 6, and then over 2.
So here, I'll write it out to make sure I don't make a mistake. I have to divide this by 3/2. But if I divide by a fraction, isn't that a keep, change, flip? So really what I'm saying here is I'm going to erase this. Maybe I'll just move this up because I want to have this in the notes.
So it's 4/3.
Really what I'm saying, yeah, it is. So this is really saying -2x to the power of 3/2 times 2/3. And then the 2 and 2 will multiply together and you get -4/3 x to the power of 3/2. All right, that was step 2. What's step 3? All right. Very well. That was a harder antiderivative. Let's try another hard antiderivative. Oh no, a fraction. It's a quotient.
They put music to it.
They're not useful. It's an antiderivative. Technically, this symbol, if you would like to know, is called integral. So, integral. So this is the integral of 3 over x squared. I'm just going to call it the antiderivative. What is the antiderivative of 3 over x squared? Because that's a better way to say it, because antiderivative implies I'm going backwards with the derivative. All right. Alden, you want to unquotient this for us?
So isn't it just 3x to the -2?
There it is. 3x to the -2. We still have to have this dx. We only are allowed to get rid of this antiderivative or this integral symbol and this dx once we actually do the rules of taking antiderivative. So let's do those rules, which means this dx and this integral sign are gone, and we're gonna do something. Do we do it to the power first? I forget this. I'm feigning ignorance. What do we do, Alden? What do we do with a power of number? I don't know. What's the first step?
Add 2. Add 1, sorry.
Add 1, yep. So this power is going to change to
-1.
x to the -1. I still have that 3 out front. And then what do I do?
Divided by 3,
Be careful.
or
Divide by
-1.
that power of -1, and then don't forget r plus c. I think it was 3 years ago, that class tried to remember the c as cake. Don't forget your cake.
Oh,
We need to remember a cake.
I will definitely.
If you forget your cake, you're going to be a very sad birthday party guest.
Do you have cake for your birthday?
I do not, but maybe. Ooh, I can send a text to my fiance. Maybe she can pick up some cheesecake. They can bring some cheesecake for you guys.
Oh, happy. Oh,
Tomorrow.
tomorrow. Okay. I thought it was today for a second.
And then I don't like divide by -1. I want to put it out front on the side. This is -3x to the -1 plus c. Okay, that looks better.
Oh, okay.
What if I do them both? A radical, there's a radical, and it's a fraction. Oh no, what do I do, Giorgio? So I'm not going to take the antiderivative yet. I'm going to say I'm
What
still
is-
taking antiderivative.
Unquotient and unradical at the same time, would that be -1/2?
Yeah, so it's x to the power of -1/2. And don't forget the negative out front.
Yeah.
Cool. So we anti-quotiented and anti-radicaled our radical quotient. And I can see that this is now clearly powerhouse. I'm going to go backwards with the powerhouse. And how do I do that, Giorgio?
First step, add 1. So we're going to go to 3/2.
There.
No,
1 positive 1/2 plus 1/2 is 3/2. But if I have negative 1/2, and I add 2/2 to it,
Is a half?
it is 1/2. Positive 1/2. Yeah, good. Positive 1/2. I still have this pesky negative up front. And then I need to do what next, Giorgio?
Divide down, so
Divide by what?
1/2.
So dividing by 1/2 is the same thing as multiplying by 2. Just gonna put 2 up front. And I see Alden already wrote it.
Oh, my cake.
Your cake, don't forget your cake. Let's see.
I ran out of room for cake.
It's done and done.
Oh, wait, I can remove the GX now.
Look how quickly we did that slightly hard problem. All right, so there are 2 houses that I need you to know today. This is powerhouse. I started off with the fun one. So there's the powerhouse, but I need to do general house. Again, there are 5 houses. There's general, trig, e, log, and if it's none of those, then it's powerhouse. So I did the powerhouse. Now I'm going to do the general. General house just means you have a letter. Oh, look, I see a letter, a letter, a letter. Those are all general house. So I call those the general antiderivatives. So I want to do these 2 first, and I'll come back to you because you're the tricky one. Whenever I have the derivative, and then I go backwards of the derivative cancel out. And this is just going to be f of x. But don't forget your cake. Oh, how easy. Oh, you want to take a stab at this one right here?
Sure. Is it just f prime?
Is f prime of x. And don't forget your
Let's see.
plus c, your cake. All right, but Mr. Sindel, what happens if you don't have any prime here? Well, you have to go backwards. So we made up notation, and this is notation that is consistent throughout all of AP Calculus, which might be different when you go to college. But in AP Calculus, when we go backwards of f and we ran out of primes to get rid of, we go to capital F. Capital F of x plus c. So if you ever see a multiple choice test that has a capital F, you need to be thinking, oh, they went backwards with normal F. They didn't have any primes yet. All right, so far so good. Here we go. How do we do this problem? And it is tricky. I'm going to give no hint right now. I want to see if you guys can just solve it. What would we do? Any ideas?
Just take the antiderivative of both.
Well, yeah, because essentially what's happening here, you can write this down in your notes too. You're taking this integral symbol and you're kind of distributing it. So this is equal to the integral of 3x squared dx plus the integral of 2x dx. You can separate them into 2 different pieces. You're allowed to break them apart, which means we just take the antiderivative of each piece. So I see Alden's already way ahead of us. Giorgio, you want to try to take the antiderivative of 3x squared, and I'll check if Alden got the antiderivative of 2x.
1x to the power of 3.
Oh my gosh, he jumped right to the answer. X to the power of 3. Yeah, that is indeed correct. And then, because just making sure everyone else followed that, 2 went up the power to 3, and then if I divide by 3, that 3 cancels out, and there's no number in front. Yeah, exactly. Alden, what about this one?
Plus x to the second.
You're able to jump as well. Yes, this one was power of 1, which went up to the power of 2. And if I divide by 2, 2 divided by 2 cancels out. And then don't forget our
Okay. You get it to the end, or could you do x3 plus c in parentheses plus x squared plus c?
Okay, well, yeah, that brings it up. So really what we have here is x to the power of 3 plus c and x squared plus c. So shouldn't I have like a 2c here? And I mean, there's some constant, right? Usually what we'd say is that's c1 and that's c2. And if I add c1 and c2 together, I get just normal c. If there's some constant. If you add together constant, it's still some constant, right? Exactly. Yeah, wow. That was pretty nice. We do have no backside on this one. Most of these notes do have a backside. I think the only one that also doesn't have a backside is 5-8. Yeah, 5-8 also has no backside. But aside from that, everything has a backside because there's a lot of notes for Unit 5. Cool. So our objective was to look at general house, look at powerhouse, and take their antiderivatives. How do you feel with that objective today? I'm just 5. 4 and a 5. All right, nice.
Do you